Hi, this is Alex from devstories.eu. Pydantic Data Validation, episode 19 of 20. Stop pulling strings out of the operating system and crossing your fingers that they cast cleanly to an integer. You have probably written dozens of utility files wrapping standard environment variable calls just to prevent a missing configuration value from crashing your application at runtime. Application configuration with Pydantic Settings replaces all of that boilerplate. While standard Pydantic handles general data validation, managing environment variables requires installing the separate Pydantic Settings package. This package provides a specific class called base settings. Instead of manually fetching variables and writing custom parsing logic, you declare a class that inherits from base settings. You define your configuration fields exactly like a standard Pydantic model, complete with Python type hints and default values. When you instantiate this class, Pydantic automatically reads your system environment variables. It maps the variable names to your class attributes, case insensitively by default. If you defined a database timeout field as an integer and the environment variable provides a string, Pydantic coerces that string into an actual integer object. If the environment variable contains arbitrary text instead of a number, Pydantic raises a clear validation error immediately upon application startup. Your program fails fast rather than crashing unpredictably later during an active database call. In larger environments, global variable names frequently collide. You might have multiple services running on the same host, all looking for a variable simply named database URL. Base settings solves this by allowing you to define an environment prefix in the model configuration. If you set the prefix to app_, Pydantic stops looking for exact field name matches. Instead, to populate a field named database URL, it specifically targets the environment variable app_database URL. Your Python application code still accesses the property as just database URL, entirely hiding the operating system prefix from your business logic. Here is the key insight. You do not have to flatten your Python objects just to read environment variables. Configuration often grows complex, requiring nested data structures. You might have a main settings class that includes a dedicated submodel for database settings and another for logging. Pydantic supports resolving these nested structures using a double_ convention. If your main settings class has a field called database, which itself points to a model containing a timeout field, Pydantic will search for an environment variable named database_timeout. If you are using a prefix, it naturally prepends that as well, resulting in something like app_database_timeout. This mechanism allows you to maintain strictly typed hierarchical configuration objects in your source code while still mapping cleanly to standard, flat environment variables. The true value of base settings is not just eliminating boilerplate code. It's guaranteeing that if your application successfully starts, its entire configuration state is fully present, explicitly typed, and entirely safe to consume. Thanks for listening. Happy coding, everyone!